Hi all, welcome. In today's class we will discuss about the third chapter in our course curriculum, which is directly going into the technicalities of the Python. So that is about objects and data types, and in that, in today's session we will discuss about the topic on numbers and variables. Okay, so in this chapter of object and data type basics we will be discussing about these following objects: numbers and variables, strings, lists, dictionaries, sets, tuples and booleans. Okay, so I want to reiterate that for many students in many of the programming languages, the variables are something that will hold the value of number. For example, let us say a variable is simply a bin which holds the value, right? So in Python, actually, what we are dealing with is initially all these data types like strings, lists, the sets, tuples, the all these things are not only data types, but they are also objects. Like for example, let us say a list. Okay, so if you define something called as a list in Python, that list is the data type and it contains the objects. It contains an objects like numbers, it can contain integers, it can contain floats, it can contain strings. So it is called a list object. Similarly, if you take a variable, for example, a is equal to 3, then a is the variable that is also an object which has an integer called 3. So therefore, in Python, these are called objects. Why I am saying this is this, in the next coming classes, when we go for loops and all those things, we'll be doing some operations on these things directly. So you need to understand that variables and objects are not different in Python. In C, it is a variable, and in C++, those things are converted into objects, and in Java also there are objects. But in Python, okay, it is a little bit different. Variables are something which holds the value, right? Correct, but those things also will act as objects. So those things we'll see in these coming classes. Okay, so the difference between the Python and other programming languages with respect to the variables are pretty important. Okay, so in other programming languages we will be declaring the variables. So once the declaration is done, the memory will be allocated. Okay, depending on the data types. So the user should be very sure of what type of variable he wants to be to declare. For example, if he wants to hold an integer variable, he needs to go for int data type. If he wants to hold a floating variable, he needs to go for a float data type. Depending on the data type, the compiler will allot the memory. Okay, then you need to assign values to the variables. So the variable contains some of the values. Okay, then you can do input output operations depending on it. You can print and read the values, and in doing so you should use proper syntax. So throughout the course, what I will be doing is that I will be bringing some analogies between the C and Python. Why I am interested in C? Because most of the students are well versed in C. So if I can bring an analogy between C and Python, they will be able to appreciate the features of Python. Okay, so let us take that analogy right from this session. So in C language, we will be declaring a variable like int a. That means a variable of data type int which holds integers. But in Python, there is no declaration. You can see here properly I have declared int. Okay, int in C language, but here I have not declared any data type to a. So this feature is called as dynamic typing in Python. Now this is one of the greatest features of Python which made it so prominent, is it automatically allots the data type. There is no need for us to declare the data type. So next is we are assigning the values to these variables, which is already done in step number 1 in Python. And next I am using the output function printf for printing. Now you can see the syntax here. Since it is an integer, I am using %d format specifier, and then I am printing a. So this returns me 5, the value of 5. And you can see in Python it's pretty light syntax, so it doesn't have these format specifiers, these inverted commas or whatever it is quotes. It is just print a. So this simple coding made it so powerful. So this is what we have been learning in my first introduction to Python. Why Python is so powerful, why people are going after Python, is because of this very simple, easy to understand syntax and simplicity in coding. Okay, so this is the difference between C language and Python in the least possible way. I have just tried to explain it. Okay, so when we go to variables, there are some features that you need to understand. The variables can be user defined. Okay, and the naming conventions, you can name it like anywhere you want, like A, B, C, or whatever it is, and you should never use the keywords. Okay, so the names of the variable should not be keywords, and there should not be any spaces in variables. If possible, you can use underscores, and a variable should not start with numbers, and there should not be any special characters. Okay, and the name should be in lowercase as in any other programming languages. Here it is called as pep 8 standards, which is called Python standards, coding standards. Okay, so this is how you should be able to define or use a variable in Python. Okay, so now what we will do is that we will just simply go to Jupyter notebook and try to do some operations on these variables and numbers. Okay, so yeah, so I have already opened my Jupyter notebook. You know how to go to Jupyter notebook because Anaconda is already installed there. Just go to your start menu and then try to click Anaconda Navigator. When you click Anaconda Navigator, you will be getting this sort of the window. Then you click on Jupyter notebook and launch. Open any browser before launching Jupyter notebook. In the respective browser, the Jupyter notebook will open. In my case, I have opened Google Chrome. Okay, so it will be like this. Once you have opened Jupyter notebook, it will be like this. Then go to new and then launch a new notebook in Python 3. Then comes this. Okay, so we are here. So in the last class I told you how to change the name of this. So I'll be changing from Jupyter demo to Jupyter variables. Okay, so I'm renaming this. Okay, so let us start this. So my first cell, I'll take a variable. I told you there is no need for any declaration of data types in Python. So let's start. Let's see what happens if we declare a data type in Python. Okay, once we will declare a data type in Python. Let us say int a. Okay, and a is equal to 3. I'm assigning the values. Then I'm using a print of a. Okay, so it's as simple as that. There is no need for you to put semicolons in Python. Okay, so what I have done, I have defined this a as int data type. I've assigned a value and I'm printing it. Now let us see what happens. When I run this, it says invalid syntax and it throws a syntax error saying that this declaration is wrong. So this is what I'm talking of. There is no need for you to declare the variable. Okay, so what we can do, just simply ignore it. So for commenting out, you should use hash in Python. Okay, so we have commented out it. So you should understand one thing, that is in Jupyter notebook is it saves. Okay, it saves automatically. Okay, so when I run this again, it prints me 3. Okay, so there is no need for you to save again like in any other IDEs. It saves automatically. Okay, so once I print this, it prints me 3. It's as simple as that. So there is no need for you to again printf %d and then print this variable name, use a semicolon. That is a heavy syntax that is there in C programming, also in Java. So that is what it makes Python so powerful. Okay, so yeah, we can do many number of operations. So let us go for addition. I will write addition of numbers. Okay, so let us take a variable a. We will assign variable 5 to this. Let us take a variable b. We will assign 4 to this. And then you can put the entire logic in one cell, or you can divide the logic in two different cells. It is up to you. I'll show you both the ways. A is equal to 5, b is equal to 4. Then I am writing a small logic of addition. C is equal to a plus b, then print C. That's it. So what I have done here is I have taken two variables, integer variables. and I have added it. I have stored that variables in C. Okay, the assignment operator, this we will learn in next coming sessions. Whatever the value you have got by adding a plus b will be stored in the variable C. Now I'm printing that. So your output should be 9. It is. Okay. So you can also do as I already told, you can also put your code in two different cells and then try it out, but you should never forget to run it. So if because c is equal to a plus b is the logic to get the values of a plus b, this first cell is the predecessor, so you should definitely run it. Otherwise this particular cell will not get the values from a and b. Okay, so first run this cell, then run this cell, so you'll get the output as 9. So why we are using two cells is for if you are not comfortable with the code, if you want to know where exactly the errors are happening, so you can go for this multi-cell approach. Okay, so this is what it gives. The Jupyter notebook is powerful application, like makes the user feel very comfortable even for a beginner. Okay, now I have printed C here. Okay. Now I'd like to show some of the features of Jupyter Notebook before we go any further. What I'll do is I'll just cut all these things. Okay. So I think you remember that the value of C is 9. Now I have not done anything. Now I'll just print this C. Okay. Let us see what happens. See, you are getting 9. So what is exactly happening is that whatever cell you have run, whatever the values of the variables are there, that will be stored in this Jupyter notebook memory. Okay, so if you want to erase that memory and then do further functions, there is one thing that you should do. Otherwise you'll be encountering this problem when you're going for a bigger codes. Okay, otherwise what will happen is that you need to close this entire Jupyter notebook, log out and then log in again. So that is a pretty cumbersome process. So what we should do is that just click on kernel and then just say restart and clear output. So whatever earlier outputs it has stored in the memory, so for C or for A or for B, for any other variable, that will be cleared. So once I press this, the kernel will be restarted. It will ask for this, just say restart, and then it will say restarting kernel. Okay, just wait for 1 second. Okay, you should get this kernel ready and then trusted. Yes, now it is ready again. Then if I again run the same command, print C, it will throw me an error. Name C is not defined. See. Okay, so this is how the Jupyter notebook is used. Okay, so I think that you have now understood pretty well of how to use the Jupyter notebook. You will get accustomed to it once you use it throughout this session. Okay then, right, so what we have done is we have added two variables. Now we will go for subtraction of variables the same way that we have done for addition. I'm using a is equal to 6, I'm using b is equal to 5, then I'll say c is equal to a minus b, and then I'll again say d is equal to b minus a. Let's see what will happen. I'm printing both c and d. Okay, so if it is a little complex for you, let me print you two statements, print c and print d. Okay, so I've assigned two variables here. I've just done my operations of subtraction. One is subtracting b from a, another operation is subtracting a from b, and then I'm printing it. Okay, so when I run this, what will happen? Let's see. 6 minus 5 is 1, it has given me 1, and d is b minus a. 5 minus 6 is minus 1, it has given me minus 1. Okay, so that is how the subtractions of variables are done. So instead of using two print statements, you can as well go for c comma d as in any other a language. So I'll again run this. You'll get 1 comma minus 1. So that's it. So it's a very simple process that you can have it in Python. Okay, then we'll go for multiplication of numbers, multiplication. Okay, so we'll take some other variables, or okay, so we'll say e is equal to 3, f is equal to 6, g is equal to e into f. Okay, and then I'm printing g here, right? So it will be 18, will be 18, as you all know. So that is all the multiplications are done. Okay, so you can as well do divisions for it. So let me do division. So when I'm talking of divisions, there are three types of divisions in Python. One is by using this forward slash. Second one is by using two forward slash. The third one is by using percentage. So we will see what will happen by using all these three division operators. Okay, so I'll just change the value for E to 6 and F to 4 for our convenience. Okay, so I will go for a G is equal to H is equal to E double forward slash F. I is equal to E% F. Okay, so I'm printing G here, I'm printing H, okay, and then I'm printing I, right? Okay, so I have got E is equal to 6, F is equal to 4, G is equal to forward slash F, E forward slash F, H is equal to E 2 forward slash F, I is equal to E% F. So we'll see what types of operations will be done here. Okay, so let me run this. Yeah, you got first one is 1.5, second one is 1, and the third one is 2. So what it is doing, I think you have already noticed it. Okay, so the first slash forward slash means it's a normal division in Python. Okay, so what it will do is it will normally divide these two values, and then it gives us the value even in float. Okay, it doesn't care whether it is these two are int, and then you should return only int like in C. But what does it do? It will do normal division, and then it gives me whatever the number is there, even with points. So second division is called floor division. So this is called as a floor division in Python. Okay, so what it does is it will not give me the decimals, it will only give me the integers. Okay, the third division is modular division. So what it will do is it will give me the remainder. Okay, so when I divide 6 by 4, my remainder is 2, so I'll get 2 here. Okay, so this is what it does. So these are the three different division parameters or operators you have. Okay, um, so you can also use BODMAS here. You can go for various things like A is equal to 10 into 5 plus 3 into 6 minus 4. So Python also accepts BODMAS. Okay, so when I run this and then when I print A, okay, you'll see what will happen. So what should happen is BODMAS, it's brackets of division, multiplication, addition and subtraction. So first it will start with division. There is no divisions here. It goes for multiplication. So multiplications is this. So 10 into 5 becomes 50. 3 into 6 becomes 18. So 50 plus 18 minus 4, that is your answer. So it is 64. Okay, so 50 plus 18 is 68. 68 minus 4 is 64. So you'll get 64. So all the BODMAS operations are possible in Python. Okay, so these are all some of the things that you should learn. Okay, in Python. So we have done addition, we have done subtraction. So we have done division. In division we have got three different operators. One is a normal division, the second one is a floor division, third one is a modular division, which will returns the decimal and without decimal and the reminders respectively. And we have also got BODMAS. Okay, so Python follows BODMAS, and this is how you need to actually go for numbers and variables in Python. Okay, so now let us go for one more sort of thing where you can have a list. So we'll be seeing about lists in the next coming classes. For the time being, okay, just say this is our list. Okay, so when I say print A, okay, it will print me the list like 1 2 2 2.53. So this is what I'm saying, this is what I said, this list. Okay, this is a list. Okay, okay, this is a list. Now list is a data type as well as an object. So that is what I told. So A is a data type called list. So how to know whether that is which data type? You just type a in this, so when you run it, you'll get list. So you can find the data types of any variables like this. So if you type here G, here H, here I, you will get these things respectively. Okay, there is no rule that you should only type it here. You can type it here as well. Okay, now let us say type of G here. So it will give you float because G is float. G is float. Okay. So that is the most powerful of Jupyter Notebook. As I told you earlier also, whatever these things will be there in the memory, though this cell will be treated as different and this cell will be treated as different. But when you run this, this cell will get linked up to the earlier cells. Not necessarily the succeeding cell or the preceding cell should have this G value. It can be anywhere in the notebook. Okay. So it is a float. You can type H as well. H, it returns an int. Okay, so now when you type a, this returned list. That means this is a data type of list. This is a list data type. Inside this data type, you are having different objects. One is an integer and it has got integers as well as float. So this entire thing is an object. So this is what I'm talking about. In my earlier just few slides back, I just told that in Python the data types are considered as an objects also. The values that these hold, so that actually makes that as an object. So we consider this as a list object. So what is this called? This is called a list object. And what is the data type? The data type is list. Okay, so this is how it is. And you can also have different types of operations. You can do a is equal to 10 and a plus equal to 10. And then if I print a, so what does it mean? We'll just see. It will print 20. That means a plus equal to 10 means it is like a is equal to a plus 10. Okay, so we'll see all of these things in the next coming classes. Okay, these are the things that I want to discuss with you regarding the variables and the numbers. Okay, hope you have understood this. So if you want to identify the type, just put this type and then find out the type of the that particular variable data type. Okay, so I hope you have understood all these concepts pretty well. See you in the next class. Bye bye. Have a nice day.